Bismillahirrahmanirrahim. Now we want to prove for this question. Prove that secant 2 theta minus tangent 2 theta equals to cos theta minus sin theta over cos theta plus sin theta. So if you can see, this one is from the double angle, okay, and this is for the single. So this one we need to use the sort of inside the proving, we need to use the double angle formula. So maybe first thing we can settle for this secant 2 theta. Okay, so we know that this value of secant 2 theta, this should be equals to 1 over cos. Okay, 1 over cos 2 theta minus, okay, the idea of tangent, we can use definitions of that. Tangent is equals to sine over cos. Okay. So as you can see, we have the same thing for the denominator. So we can get 1 minus sine 2 theta over cos 2 theta here. Okay. So now you can see that we have, okay, all this double angle. Now we need to apply with the identity. So it should be 1 minus 2 sine theta cos theta. Okay. Divide with cos 2 theta. If you noted, we have 3 identities related to cos 2 theta. But maybe we can check on the pattern or the form of the equations that sort of the right hand side term here. So it involves cos theta minus sin theta, and this is plus. So if you can see, this one maybe involve the identity that cos square theta with sin square theta. Okay, so we will choose that one. This cos 2 theta should be replaced with cos square theta minus with sin square theta. Okay, so the term that we have at numerator here, in terms of 1 minus 2 sin theta cos theta. Okay, so is there anything that we can replace with 1? Okay, so we know that the identity of cos square theta plus with sin square theta is equals to 1. So we can use this. So minus with 2 sin theta cos theta. Okay. So it should be divided here with cos square and sin square. Okay, so next should be factor or the simplification for the numerator part. Okay, if you noted, this is cos square, this is sin square, and this is 2 sin theta cos theta, right? Okay, so if you recall, how can we factor for the terms that we have is a, okay, so a square, for example, plus with a plus a minus a minus b square. So a minus b square, it should be a square minus 2ab minus ab minus ab, so minus 2ab plus with b square. Okay, so that you can see we have this is a square cos square, we have b square here sin square, and then minus 2ab, it is minus 2 sin theta cos theta. Okay, so sort of if we factor our terms in terms of cos, let's say put it cos theta minus with sin theta square. Okay, so we will get cos square theta minus cos theta minus sin theta twice, so 2 cos theta sin theta, and then we have one more with plus of sin square theta. Okay, so as you can see, this one we have this cos square sin square here, and this is 2 cos theta sin theta negative. Okay, so we should continue our factor. So this one should be replaced with cos theta minus sin theta square, all the things there as numerator. Okay, so the term for denominator, okay, this one again we need to recall the idea of factorization. Okay, so if you noted, this one in terms of cos square theta with sin square theta. So if you have a square minus b square, this should be a plus b and a minus b, right? So that the term that we have now can be replaced with cos square theta plus, no more square, so cos theta plus sin theta with cos theta minus sin theta. Okay. So if you noted, this is cos theta minus sin theta, and this is cos theta minus sin theta. So we can simplify one of that. So now the degree left is 1. Okay. So the final answer should be cos theta minus sin theta divide with cos theta plus with sin theta. Okay, so as you can see, now the terms that we have here, okay, this one, this is equals to the given equation. So we complete the proof.